Hello everyone. In this video, I am going to discuss the remaining solution of data science and semester paper. I had already discussed the question number first A and B part, question number second A part and its B part, the solution of question number third A part and its third B part. I had also discussed the solution of fourth question A part and its B part. I had also discussed fifth question A part, its B part in the previous video. In the previous video, I had also discussed this question number 6 A part and its B part solutions. So let's begin with the seventh question. The seventh question is asking to write a k-means clustering algorithm and discuss how the initial centroids influence the results. So uh, the algorithm or the k-means clustering algorithm categorizes the items into k groups of clusters of similarity using the distance metrics like the Euclidean distance or Minkowski distance with k is equal to 1, that is Manhattan distance metric. The algorithm works like first it initializes, that we begin by randomly selecting the k cluster centroid. Then we perform the assignment step in which each data point is assigned to the nearest centroid forming the cluster. After that, we update the steps by after the assignment, we recalculate the centroids of each cluster by averaging the points within it. After that, we repeat these steps. This process will be repeated until the centroids no longer changes to the maximum number of iterations is reached. So, discuss how initial centroids influence the result. So, if the initial centroids in the k-means clustering algorithm critically shape the final outcome, as if the centroids are chosen poorly, then they can lead to suboptimal cluster or slower convergence to the result or empty cluster, while when chosen centroid can give us more accuracy, improved stability and speed in the cluster formation. I had also given a common example in the real world scenario in IPC-BNS section prediction, where we have to cluster 50,000 information reports, FIR reports, first information report, into k natural crime groups like the dowry rate, honor killing, or land dispute murder to inform the policy or BNS section petition. First, we will make an assumption and perform the pre-processing, like we have to take the assumption of victim age scaled, marriage duration using scaling, dowry demand using encoding, burn injury, which will also be encoded, then thread calls count, which will be scaled, weapon type will be one hot encoded, then relationship with the execute, which will be also one hot encoded. Then we will perform the data preparation. We will uh, assign all features such that each one will be numerical and appropriately scaled or encoded before use. For the target k centroid, we will assume the range for k is 5 to 7, which will be based on the expected number of distinct crime types, and we will assign the following clusters. Uh, the k cluster for the given types of the data. Let's move to the part B solution of the question number 7, which is asking to write the k nearest neighbor algorithm, KNN algorithm using the Euclidean distance. So we will firstly take an input in the algorithm. Training dataset will with features and labels which will be our input. We will use the test point or query. Then we will also determine the number of neighbors or k neighbors. We will calculate the distance by using the Euclidean distance or some other distance metrics, but here we have been asked for Euclidean distance, so we can calculate it by calculating the distance between 2 points P and Q as under root of summation of I is equal to 1 to n Pi minus Qi the whole square. And then we will sort the neighbors. Sorting will sort the training points by ascending distances, and we will then select the top k value. We will pick the first k nearest neighbors and we will perform majority voting, that is classification. We will count the labels among the k neighbors and assign the label with the highest frequency. And finally, we will perform averaging in like the regression we can use a regression technique. If we are using the regression, then we will return the average of the k neighbor values. Let's move to the next question. Question number 8, A part, is asking to compare decision trees, random forest, best, boosting, and highlighting the strengths and weaknesses of each. First of all, decision trees. Decision trees are very easy to interpret, whereas random forests are less interpretable, which are generally an ensemble of many trees. So it is less interpretable. In boosting, the boosting method makes it very hard to interpret due to the sequential complexity. In decision trees, overfitting risk is very high, especially with the deep trees. In random forest, there is a reduced risk of overfitting where we average the many trees. In boosting, it can overfit if too many iteration or poor tuning is done. Decision trees provides moderate accuracy, which depends on the depth and pruning, whereas random forest provides high accuracy, which is generally better than the single trees. Boosting also provides very high accuracy, which often is state of the art on the tabular data. Decision trees are sensitive to the small changes in the data, whereas random forests are robust to noise or small changes and missing values, where boosting is also sensitive to the outliers. Decision tree require is very fast to compute, and it trains and predict very quickly. Random forest performs slow training or prediction with many trees, and boosting, uh, the process is computationally expensive, and especially with the large datasets, it takes a very long time to compute. In decision trees, the bias variance trade-off is such that it has low bias and high variance. In random forest, the bias variance trade-off is balanced. In boosting, the bias is generally low and the variance is controlled by the learning rate and the iterations. Now let's discuss the B part of the question number 8, which is asking to explain the architecture and components of Hadoop HDFS, which is Hadoop Distributed File System, Yarn, yet another resource negotiator, and MapReduce method, or describe Spark and its advantage over MapReduce. So I have discussed the what is an Spark and its advantage over MapReduce. Apache Spark is an open source distributed data processing engine which is generally used for large scale analytics, supporting batch, streaming, SQL, machine learning, and graph processing via RDDs or resilient distributed datasets and a higher level API. The major disadvantage of Spark over MapReduce includes the following aspects, like the processing speed. It is very quick in processing, 10 to 100 times faster via in-memory caching, whereas MapReduce is slower, which performs disk writes after each map or reduce function. The data storage of Spark is uses RAM. RDD is persistent across jobs, whereas in MapReduce, the data storage is done in the disk for intermediates. In Spark, programming is not so good as it requires high level APIs like Scala, Python, Java, R, or SQL. Where in MapReduce, the programming is ease as it requires Java or verbose MapReduce functions. In Spark, workload support is such that it it uses batch streaming, ML, or graphs. In MapReduce, workload support is provided by batch only. In Spark, the fault tolerance is such that the RDD lineage for the computation is used. For fault tolerance in MapReduce, HDFS replication or task retries are used. The use cases of Sparks include real-time analytics, iterative ML, etc. Whereas use case of MapReduce include the large-scale batch ATL. Let's move to the question number 9, A part, which is asking to obtain the basic logic gates from neural networks and summarize them in the table with the number of neurons, activation function, and backpropagation in neural networks, if any. So, I had created a general table to explain each one of them. The gate AND gate is created by using two inputs, zero hidden and one node or a single perceptron, or two input, two hidden layer and a single output layer. The activation function for the AND gate is sigmoid or step threshold, and the backpropagation is for AND gate is optional. For multi-layer, it may be used, but it is optional. It is used to train the weight. For the OR gate, we will use two input layers, zero hidden layers, and a single perceptron. A single output layer, or similarly, two input, two output, and a single output layer. The activation function for OR gate is also a sigmoid or step backpropagation. The backpropagation for the OR gate is optional. NOT gate is created using a neuron with a single input layer and a single output layer. That is also called a single perceptron. Activation function is a step, that is invert threshold, and the backpropagation is none in this gate that uses fixed weights. Okay, NAND gate is such that it is created using a neuron with two input gates and a single output, two input layer and a single output layer, that is called a single perceptron, or two input layer, two hidden layer, and single output layer. The activation function for the NAND gate is a sigmoid or a step, and the back propagation for NAND gate is optional. NOR gate. For the NOR gate, the neuron is such that it contains two input layer and a single output layer, or two input, two hidden, and a single output layer. The activation function for NOR gate is also a sigmoid or step. Back propagation for NOR gate is also optional. XOR gate. For XOR gate, two input layer, two output layer, and a two input layer, two hidden layer, and a single output layer is used, and it requires multiple layers. Its activation function is sigmoid with both the layers, and back propagation is present in XOR gate. That is essential for learning. Let's discuss the B part of the question number 9. That is asking to compare CNNs, RNNs, GNNs, and transfer learning in terms of architecture and application. So, CNN. The architecture of CNN is convolutional. That is the pooling layers, convolutional plus pooling layers extracting spatial features. It contains fully connected output. Application of CNN is in image classification, object detection, medical imaging. The recurrent neural network (RNN) contains recurrent loops with hidden states for sequential dependencies that contains LSTM or GRU variance address vanishing gradients. Whereas application of RNN is in time series forecasting, natural language processing, example translation, speech recognition, etc. The architecture of GAN contains a generator that creates the data versus the discriminator that detects the fakes. It is contains an adversarial training, and its application is used in image generation, style transfer, data augmentation, etc. Next, transfer learning. The architecture of transfer learning such that it contains pre-trained model. Example CNN like ResNet, fine-tuned on new tasks with fewer layers or parameters. An application of transfer learning include domain adaptation, low data scenarios, for example, custom image classification, etc. So with this, I discussed all the solution of the end semester question paper. Thank you very much for listening.